Hi all. So welcome back to the lecture series of linear control systems. So in this video we are going to discuss the problems based on the time responses. So listen here. The problem is, the first one is, a positional control system with velocity feedback is shown in the figure. So what is the response of the system for unit step input? So here we have to find the response, that is the C of S. So actually the response means we have to take the Laplace inverse of that C of S, that is the response in time domain, C of t. So we have to find C of t. Okay, and also in that you may be familiar with the systems with the unity feedback, and you have done the problems based on that unity feedback. But here a feedback gain is already given here, that is 0.1 s plus 1 is the feedback gain, that is instead of h of s we have to take this value. Okay, so the first step is to find the closed loop transfer function of the system, that is C of s by R of s. We know the equation is g of s by 1 plus g of s into h of s, and also we know that the g of s is here, it is 100 by s into s plus 2, and h of s is 0.1 s plus 1. So just substitute those values and we will obtain C of s by R of s as 100 by s square plus 12s plus 100. Okay, so this is our closed loop transfer function. Okay, by just solving the equations we will obtain the transfer function as 100 by s square plus 12s plus 100. Okay, and we know that the input is unit step. Okay, we have to give a unit step as the input. So always the R of s, that is the input R of s, will be 1 by s. Okay, that is C of s we will obtain by multiplying our transfer function with R of s. So here the R of s will be equal to 1 by s because it is a unit step input. Okay, suppose there may be conditions like that. There may be said that if you are giving an step input of amplitude 3 or 4 like that. Okay, so in that conditions we have to take the input as 3 by s, 4 by s like that. Okay, 3 by s, 4 by s like that. Okay, so that's the only difference. So here the input is, it is unit step, so R of s will be 1 by s. Okay, so just substitute the value of R of s in the equation. We will obtain C of s as 100 by s into s square plus 12s plus 100. Okay, and we have to find the Laplace inverse of this function. Okay, then the question is complete. Okay, so for taking the Laplace inverse we have to use the partial fraction expansion technique, that is we have to divide the systems into different parts. Okay, thereby it is very easy to find the Laplace inverse. So here by observing the function we know that there are two terms, so we are splitting it to 2, that is yours as a by s plus this is a quadratic term, so the partial fraction numerator becomes bs plus c here, so bs plus c by s square plus 12 plus 100. So we have to find this a, b and c. Okay, after finding that a, b and c, just substitute in this equation and find the Laplace inverse. Okay, so for finding a, b and c we are using the technique like that, that is a can be found by multiplying our transfer function c of s by the denominator of a. That is, for finding the a we have to multiply this entire c of s with the denominator s, and we have to equate the value of s as 0 because the root here is 0. Okay, so c of s, that is 100 by s square plus 12 plus 100 into s. Okay, at s equal to 0. Okay, so here we know that when we are multiplying this term with s, okay, this term with s, this s and s will be cancelled. Okay, that you can see here, and after that we have to substitute the value of s as 0 here. Okay, so by substituting the values of value of s as 0 we will obtain the constant a as 1. Okay, so a is 1, and we have to find b and c. Okay, so finding the b and c, okay, mainly because this is a quadratic equation, so we can simply find the value of b and c by cross multiplying the values and equating that to 100. Okay, so by cross multiplying it and equating to 100 we know that we will get it as 100 is equal to a into this term, that is s square plus 12 plus 100 and plus bs plus c into s. Okay, and after that we are equating the coefficients of s square. Okay, by equating the coefficient of s square we will obtain as 0 is equal to a plus b, and we know that the value of a is 1 here, so b will be, of course, it will be minus 1. Okay, and after equating the value of coefficients of s, okay, coefficient of s, we will obtain it as 0 is equal to 12a plus c. That is, also we know that a is 1, so c will be minus 12. Okay, and after that we have to substitute the value of a, b and c in the main equation. Okay, so just we have substitute the values of a as 1 and b as minus 1 and c as minus 12. Okay, you can see here, and we are taking out this minus common. Okay, that is, this minus is common for the s and 12. Okay, so the equation becomes like this, and after that, by observing this equation, the Laplace inverse of this one will be very, very difficult. Okay, so if we have to change this into some different form, okay, some another form, we can easily find the Laplace inverse. So for that, we know that the Laplace transform of cos omega t is, okay, cos omega t is, that is s square plus s by s square plus omega square, and also we know that the Laplace transform of sin omega t will be omega divided by s square plus omega square. Okay, so if we can change this equation, okay, this entire equation into some form of cos omega t and sin omega t, it will be very easy to find the Laplace inverse. Okay, so for that, we are making the denominator term a full square. Okay, that is, by observing the second term here, it is s square plus 12s. Okay, so we know that the equation of a plus b whole square, okay, a plus b whole square, we know that it is a square plus 2ab plus b square. Okay, so by comparing with this equation, okay, this equation, we know that a will be s and b will be, of course, it will be 6. The value of b will be 6. Okay, by observing this equation. Okay, so we can easily convert this entire equation into a full square form like that, that is s plus 6 all square. Okay, so here it is 100. We know that when we are taking the s plus 6 all square, it will be s square plus 12 plus 36. Okay, so just here we are just splitting this 100 into 36 plus 64. Okay, so therefore we can take this as s plus 6 square and this one as 8 square. Okay, and also we know that this is s plus 12, and here also we are splitting it as s plus 6 plus 6. Okay, and after that we have to just split this second term into another 2 times. Okay, that you can see here, it is 1 by s minus s plus 6, s plus 6 divided by s plus 6 plus s plus 6 all square plus 8 square, then minus 6. Okay, minus 6 by s plus 6 all square plus 8 square. Okay, so here we know that this is the form of a cos omega t, and this one will be something like a sin omega t. Okay, sin omega t. Okay, so for that, here it is exactly correct, that is like that, s by s square plus omega square, but here it is 6 by s plus 6 all square plus 8 square. Here when we are comparing with our sin omega t equation, Laplace transform of sin omega t, it will be omega by s square plus omega square. Okay, so but here by observing this term, the value of omega will be root 8. Okay, sorry, the value of omega square is 8, so the value of omega will be 8. Okay, so that the same value of omega should be there in the numerator. So for that we are just multiplying and dividing a term. Okay, dividing this term with 8. Okay, so that this we can easily taken outside 6 by 8 at constant, and 8 by 6 8 by s plus 6 all square by 8 square as the Laplace transform of the something like a form of our sine. Okay, so by converting the entire equation in this form, we are taking the Laplace transform, and here we know that Laplace inverse. Here the Laplace inverse of 1 by s is 1, and the Laplace inverse of s plus 6 by s plus 6 all square plus 8 square, we can take it as e raised to minus 60 cos 80. E raised to minus 60 cos 80 will be the corresponding Laplace inverse, because we know that the Laplace transform of e raised to minus 80 cos omega t, Laplace transform of e raised to minus 80 cos omega t, okay, will be s plus a divided by s plus a all square plus omega square. Okay. By using this equation, we can take the Laplace inverse very easily. So here instead of this a, the value of a, here it is 6. Okay, here it is, instead of this value of a it is 6, and instead of the value of omega it is 8. Okay, so we can easily write the Laplace inverse as e raised to minus 60, because a is 6. Okay, cos omega t, cos omega, instead of this omega we are having 8, so e raised to minus 60 cos 80. Okay, and likewise here it is in the form of a sine. Okay, so 6 by 8 e raised to minus 60 sine 80. So at last we will obtain it as 1 minus e raised to minus 60. We are taking outside e raised to minus 60 common, so it will become 6 by 8 sine 80 plus cos 80. Okay, and after that we are just comparing with our actual second order function, that is the second order transform function with our standard second order transform function for obtaining the value of theta and omega n. So by comparing with that, we will obtain it as omega n square will be equal to 100, so omega n will be 10, and 2 theta omega n. Okay, here it is sorry, a small mistake is there, that is here it is 2 theta omega ns. Okay, 2 theta omega ns plus omega n square. So by comparing with our equation, we know that the 2 theta omega n will be 12, and from that we will obtain it as theta as 0.6. Okay, why we are obtaining this? Because we have to just convert this equation, okay, into some another form, okay, into a very simpler form. Okay, we know that by using a right angle triangle having sides theta root of 1 minus theta square 1, we can simply replace the terms with the cos theta and sin theta, like that. Okay, because we have already learned the cos theta, the value of cos theta as theta, and the value of sin theta. Okay, and the value of sin theta as root of 1 minus theta square. Okay, so using that equations we can construct a triangle, like a right angle triangle, like that, having sides theta and root of 1 minus square and 1. Okay, so from that we obtain cos theta as theta, that is 0.6, and sin theta as root of 1 minus theta square, that is 0.8. Okay, so if we can add these values, that is 0.6 and 0.8, in our actual equation, okay, we can also reduce our entire equation to a smaller one. Okay, so for that we are taking outside from this term we are taking outside a value 10 by 8, because here if you are taking, that is if you are taking the value of 10 by 8 common from these two values, the first value becomes 6 by 10. Okay, that is, which means 0.6, that is equal to cos theta here. Okay, and in the second term will become what, 8 by 10. Okay, it will become 8 by 10, because we are taking outside 10 by 8, so it will become 8 by 10. So it is also 0.8 will become here, 0.8 will be here though, so we can substitute for sin theta. Okay, so here you can see this 6 by 10 becomes 0.6 and 8 by 10 becomes 0.8, and we are substituting 0.6 as cos theta and 0.8 as sin theta here. Okay, and we know that this is in the form of sin a cos b plus cos a sin b, which is equal to we know that is sin a cos b plus cos a sin b. Okay, which is equal to sin of a plus b, so here the equation becomes sin of a plus b means sin of 8t plus theta, sin of 8t plus theta. Okay, and we know that the value of theta here, what is the value of theta? That is tan inverse root of 1 minus theta square by theta. Okay, we are using the equation tan inverse root of 1 minus theta square by theta, so it becomes 0.925 radian. Okay, always the theta should be in radians. Okay, so by taking this equation, we know that we will get it as degree, that is 53 degree. So for converting into radian, we have to multiply with the pi by 180, so it becomes 0.925 radian. Okay, so we have when substitute the theta as 0.925 here, and our last answer is 1.125 into e raised to minus 60 sin 80 plus 0.925, that is, which is something more simpler than this function, that is we have eliminated a term cos. Okay, cos 80 here. Okay, So thank you. I hope all of you understand the problem well, and thank you.